Namaskar. Welcome to the section on traditional food and sensory science. Introduction. Food is enjoyed for its good texture and it plays an important role in overall acceptance of a product. Pleasure is derived from taste, smell, temperature and vision of food and also perceptual texture and sensation that is the most relevant consideration of food structures. The awareness of food texture was found at the subconscious level and is usually pushed to the background in flavorful foods. The concept becomes clear and effect accentuated when deviation from the expected texture of foods are noticed and is more important in bland and crisp or crunchy foods. Following aspects should be dealt to understand texture under sensory analysis in this chapter. Definition and importance of texture, phases of oral processing, texture perception and receptors involved, rheology of foods, classification of texture and texture measurement. Now let us come into the definition and importance of texture. The attribute texture is clearly a sensory attribute. It is a resultant of a combination of physical properties perceived by the senses of touch, sight and hearing. In its broadest scope, the texture was defined by Jowett as the attribute of a substance resulting from a combination of physical properties and perceived by the senses of touch including kinesthesia and mouthfeel, sight and hearing. Physical properties may include size, shape, number and conformation of constituent structural elements and so is described to engulf consistency and rheology as illustrated by the work of Czerniak and co-workers and Jowett. Further, it may be defined as sensory manifestation of structure or inner makeup of products in terms of their reactions to stress measured as mechanical properties, tactile feel properties measured as geometrical properties and other mouthfeel properties. Food texture has been an area of brisk and vigorous research over the years. The interest and time spent on it could be seen by work on meat and fruits on one hand and other spreads on the other. An exclusive journal, that is the Journal of Texture Studies, has been devoted to the area since 1969. It has been recognized that quantitative changes in the intensity of attributes need to be measured and then finally relate them to the measures of overall quality for meaningful investigations. But it remains for the researchers to develop product-specific methods because a term has a different meaning for different foods. For example, firmness is applied to butter and carrots and tenderness is applied to meat and beans. A precise definition may not always be possible, but a reference can be defined in units more stable and universal than those terms. Phases of oral processing. Processes leading to perception of texture are as follows. Figure 1. Information about the textural characteristics of foods may be obtained prior to mastication. The visual appearance of the sample may provide some clues. For example, the color of fruit may indicate its taste of ripeness and hence its firmness. The limp appearance of a leafy vegetable would suggest a lack of crispness. When a sample of a solid food is manipulated in hand by squeezing, impressing or bending or is cut with a knife or penetrated with fork, clues as to its firmness, toughness or crispness or fibrousness may be revealed. Initial perception in the mouth is at a relatively low shear rate. Two categories of sensation have been identified. Those due to touch, which occur regardless of any shearing, and those that require a small amount of shearing and those that require small amount of deformation. With no shear at all, we gather impression about the food's homogeneity, such as the presence of size and shape of particles or air cells. At slightly higher shear rate caused by movement of the tongue, the food is deformed and flows under these conditions. Characteristics such as elasticity, stickiness to the palate, and viscous behavior are perceived. During the first few chews, much of the structure is broken. Next is texture perception and receptors involved. Often, sensory assessments of texture are made on the basis of the sensations perceived where the food is manipulated in the mouth, that is, where it is introduced, bitten, masticated and swallowed. During such manipulation, there is a reciprocal interaction between the texture of the food and the buccal work acting to change the structure to state suitable for swallowing. Apart from the use of sensory techniques, there are three other general approaches to the study of textural properties of foods. The most common involves the use of instruments to evaluate the physical properties of the samples. Another is to examine the structure of the foods, and third is to determine their chemical composition, in particular that of their structural components. The group of perceptions generally described as the sense of touch can be divided into somesthesis, that is tactile sense, skin feel, and kinesthesis, that is deep pressure sense or proprioception, both of which sense variation in physical pressure. Several types of nerve endings in the skin surface are epidermis, dermis and subcutaneous tissue. These surface nerve ends are responsible for the somesthetic sensations we call touch, pressure, heat, cold, itching and tickling. Deep pressure, kinesthesis, is felt through nerve fibers in muscles, tendons and joints, whose main purpose is to sense the tension and relaxation of muscles. The nerve fibers are buried within a tendon. Kinesthesis perceptions corresponding to the mechanical movement of muscles, that is heaviness, hardness, stickiness, etc., result from stress exerted by muscles of the hand, jaw or tongue and the sensation of the resulting strain, that is compression, shear, rupture, within the sample being handled, mastication, etc. The surface sensitivity of the lips, tongue, face and hands is much greater than that of other areas of the body, resulting in ease of detection of small force differences, particle size difference and thermal and chemical differences from hand and oral manipulation of products. Next is rheology of foods. Flow properties of foods are defined as rheology of food. The complex nature of foods' variability and their diverse behavior are some of the reasons for grouping separately the flow behavior of specific foods. The rheological properties of solid foods play a vital role in the manufacture, quality control and product development of foods. The knowledge of fundamental properties is important as well as that of empirical and limitative and imitative properties. The effect of temperature on apparent viscosity has been described by Arrhenius relationship. Many rheological equations have been used to describe the flow properties of fluid foods, but the power law and Casson flow models have been found the most extensive use. Viscosity function of N can be used to classify the flow behavior of several foods. The viscosity of Newtonian foods is influenced only by temperature and composition. It is independent of the shear rate and previous shear history. Foods known to be Newtonian are milk, filtered orange or apple juices, etc. Foods that do not follow Newtonian behavior are called non-Newtonian foods. The flow properties of non-Newtonian foods are influenced by the shear rate. Apparent viscosity is defined as ratio of the shear stress to shear rate. Non-Newtonian foods can be divided into two categories, that is time independent and time dependent. At a constant temperature, apparent viscosity for the former depends only on the shear rate. A large number of non-Newtonian foods, fluid foods, exhibit pseudoplastic behavior, and these foods are melted chocolate wheat flour, suspension, concentrated fruit juices, fruit and vegetable purees, and gum solution. Several instruments are used to measure flow property. Rheometers are used to get information on rheological parameters such as those related to viscoelastic behavior. Figure 2. The rheological properties of solid foods play a vital role in the manufacture, quality control, and product development of foods. The knowledge of fundamental properties is important as well as that of empirical and imitative properties. Now, next coming to classification of texture. Szczesniak is in as early as 1963 published a classification of textural terms which are still in widely use in their original or modified forms. The three major classifications are mechanical characteristics relating to the reaction of food to stress, primary hardness, that is force to attain a given deformation, hard boiled candles, cohesiveness, that is the degree to which sample deforms, example toffees, secondary, that is adhesiveness, force required to remove sample from a given place, chewiness, brittleness, geometrical characteristics relating to size, that is smooth, powdery, mealy, shape and orientation of the particles with the food, that is flaky or spongy. Other characteristics relating to moisture and fat contents of food, for example juiciness, creaminess. The mechanical characteristics have been subdivided into primary parameters of hardness, cohesiveness, viscosity, elasticity and adhesiveness, and secondary parameters of brittleness, chewiness and gumminess. Further, Jowett in 1974 proposed a glossary of textural terms arranged into four main categories, that is general, which is the structure, texture and consistency; terms relating to the behavior of materials under stress, for example firm, soft, sticky, crisp and thick; terms relating to the structure of the material; relating to particle size and shape, for example smooth, powdery, gritty and meal; relating to shape and arrangement of structural elements, for example flaky, fibrous, spongy; terms relating to mouthfeel characteristics, for example juicy, greasy and creamy. Texture measurement, basic rheological models. Texture measurement and recent advances in texture evaluation. Rheological models. Food materials have viscoelastic properties when they are exposed to various conditions of stress or strain. Researchers have found rheological models to be useful in predicting mechanical response of foods to specific stress-strain conditions. Two of the most useful rheological models are static creep and stress relaxation. In the creep equipment, when the load, that is force, is applied to the sample is rapidly deformed, giving a strain on the material, which continues to increase at a decreasing rate as a function of time. Stress relaxation can be described as the ability of a material to alleviate an imposed stress under conditions of constant strain. The most common principle employed in instrumental texture measurements is to cause a probe to come into contact with the sample is deformed and the extent of deformation or resistance offered by the sample is noted and used as an index of the texture of the food. Some instruments are designated to measure correctly defined mechanical or physical properties of food samples such as modulus of elasticity and viscosity. These instruments measured forces and deformations with better precision, and a number of test calls could be used through appropriate adapters. The emphasis has been on product-specific method based on systematic procedure. Dynamic testing methods offer a promising new techniques in the evaluation of physical properties of foods. Resonance methods have been used to measure maturity or texture of fruits and vegetables. To measure textural properties, the food is deformed to apply compression, tension, shear and combination of these operations, and the reactions of the sample to the applied forces is measured. Within each class, the instruments can be further divided into three types. First is fundamental. Classical material test techniques are used to deform a specimen of defined shape in a specific way so that all test parameters are known and the results can be readily analyzed by rheological theories. Fundamental tests are the ideal methods of texture testing because it is possible to determine one or more physical contents that describe exactly the properties of the food in terms of well-defined parameters. Next is initiative. Mechanisms are designed to initiate a specific human operation on the food, such as chewing the food or squeezing it by hand. For example, strain gauge dexturometer, Proctor et al. 1955. The objective is to reproduce the motion and deformation applied during human evaluation and assume that the reaction forces developed by the sample represent human reactions. Next is empirical. Foods are subjected to mechanical deformations which applies a sequence or combination of stresses. For example, compression, tension, shear, flow, extrusion, and the sample reaction is recorded. Example, Warner-Brasler meat shear test, Kramer shear press. Kramer shear. It was developed initially for quality evaluation of fresh vegetables. It shears, compresses, and the weight of the food has a power law effect on the maximum force recorded. It is used for measuring maturity and textural properties of fruits and vegetables. Warner-Brasler shear is used for measuring toughness of meat. The test cell consists of a thin stainless steel blade with a hole. Two metal anvils move down on each side of the blade and shear the sample material. Penetrometer. It was developed to measure semi-solid foods such as puddings, gels and jellies. The penetrometer consists of a cone, needle or sphere attached to a short rod that can be mounted on the crosshead of a universal testing machine. Collection of descriptors for perceived attributes of texture in a food product to the prospective panelists by presenting them the widest feasible range in eating quality. Selection of impact attributes and resolution of semantic problem through panel participations and literature consultation. Identification of levels clearly distinguishable through providing descriptors for each attribute and definition of optimum level for each attribute. Selection and standardization of an instrumental method and calculation of relevant parameters to describe the impact attributes. Establishing relationships between sensory and instrumental measures for predictive purposes and other validation. Other equipment used in the recent years are texture analyzer, that is SMS, texture measuring system, that is Instron and Lloyd's, TPA curve for the deformation extent of deformation and resistance offered. Different blades are used for measuring different textural parameters of different foods. For example, compression is used for measuring dough consistency, penetration for fruits, vegetables tenderness, shear for the tenderness of meat, extrusion for jams and jellies, breaking strength for biscuits, Cramer shear for samosa, fruits and vegetables. Typical texture profile curve can be seen as given below in figure 4. The 5 measured and 2 calculated parameters are as follows. Fractionability is defined as the force at the first significant break in the first positive bite area, that is A1. Hardness is defined as the peak force during the first compression cycle, that is height of first peak A1. Cohesiveness is defined as the ratio of the positive force area during the second compression cycle to the positive force area during the first compression cycle, that is A2 divided by A1. Adhesiveness, that is stickiness, is defined as the negative force area for the first bite, representing the work required to pull the plunger away from the load sample, that is area of negative peak. Gumminess is defined as the product of hardness and cohesiveness, that is hardness into cohesiveness. Chewiness is defined as the product of gumminess and springiness, that is gumminess multiplied by springiness. Springiness is defined as the height to which the food recovers during the time that elapses between the end of the first bite and the start of the second bite, that is D2 divided by D1. Texturometer evaluation of mechanical parameters of a food correlated well with scores got by the use of a trained texture profile panel. This correlation indicates that General Foods Texturometer has the capacity to measure certain characteristics with a type and intensity similar to those perceived by the human mouth. Borne in 1978 was the first to apply the texture profile analysis techniques. He also said that Instron generated force curves can be calculated into Newton's units. Sensory properties include whatever we smell, taste, see, hear and feel with our senses and are manifest in the flavor, texture and appearance of products. Fast reproducible estimates of a bakery product's sensory properties of chemical, physical or instrumental measurements can be developed only when we adequately understand the sensory processes. Texture measurement, applications in few foods, processing and biscuit. Baking is a process by which the raw ingredients are subjected to cooking and drying along with the development of texture, color and flavor so that the final product is made palatable. Many attributes of bakery products, like all food products, can be measured only by sensory techniques, as some chemicals are additive and others are suppressive. The amount of sweetness or bitterness that a person perceives does not relate directly to the amount of sugar, acid or bitter components measured by chemical methods. Crispness, cohesiveness during mastication and acceptability are only a few of the many characteristics that cannot be measured by any physical or chemical test. Understanding the sensory perception process and the interrelationships of sensory properties to acceptability is fundamental to successful marketing of finished bakery products. Ingredients and biscuit texture. The quality of finished bakery products depends on various parameters like processing conditions, formulae, method of preparation, etc. The quality of raw material is the prime and the most critical criteria to produce quality products. Refined wheat flour provides the framework for baked goods, retains the gas during baking and forms the structure of biscuit. Sugars impart sweet taste, top biscuits, create tenderness and firmness of texture, partly by weakening the gluten structure. They contribute to the crust color of biscuits. Fats and oils tenderize the product and soften the texture, improve the palatability of the biscuit and add flavor. Water acts as a dispersing agent for ingredients, helps in the aeration of biscuit and gelatinizes the starch. Leavening agents increase the volume of the products, make it more porous, crisp and palatable. Texture parameter assessed in few foods. dairy products. Emulsifiers improves tenderness, flavor release, increase the volume and improve the texture and spread. In cheese, surface, that is bumpy, grainy, gritty, wetness, oily or fatty, loose particles. First bite or first chew, firmness, hardness, denseness, cohesiveness. Partial compression, springiness. In potato chips, the surface, that is oiliness, roughness, macro, roughness, micro crumbs. First bite or first chew, hardness, crispness, denseness, particles after 4 to 5 chews. In bread, surface, that is crumb texture, roughness, loose particles, moistness, crust texture, roughness, loose particles, moistness. First chew, crumb denseness, crumb cohesiveness, crumb firmness, crust hardness, crust denseness, crust cohesiveness. Conclusion. The awareness of food texture was found at the subconscious level and is usually pushed to the background in flavoral foods. The concept becomes clear and effect accentuated when deviation from the expected texture of foods are noticed and is more important in bland and crisp or crunchy foods. Texture was defined by Jowett as the attribute of a substance resulting from the combination of physical properties and perceived by the senses of touch, including kinesthesis and mouthfeel, sight and hearing. The most common principle employed in instrumental texture measurements is to cause a probe to come into contact with the sample is deformed and the extent of deformation or resistance offered by the sample is noted and used as an index of the texture of the food. Some instruments are designated to measure correctly refined mechanical or physical properties of food sample, such as modules of elasticity and viscosity. Texturometer evaluation of mechanical parameters of a food correlated well with scores got by the use of a trained texture profile panel. This correlation indicates that General Foods Texturometer has the capacity to measure certain characteristics with a type and intensity similar to those perceived by the human mouth. Thank you.